This is problem number 45 from page 144, and we're solving radical equations. To undo a square root, you square. So what we want to do is square both sides of the equation. I want to remind you, though, that squaring a side is different from squaring each individual term. So you would know, just if we looked at some numbers, that 1 plus 2 quantity squared is not going to be equal to 1 squared plus 2 squared. So squaring a quantity is different than squaring the individual terms. So taking that idea over here, I'm squaring the whole side. I'm not squaring the individual terms. And squaring a binomial like this really is the FOIL process. So if we write out what we're about to do, we're multiplying this term by itself. That's what we're about to do. And over here, we just have one quantity squared, so the square root sign and the squared cancel. Okay, so let's multiply the firsts, and we get x plus 7. Let's multiply the insides, and we get 3 times the square root. The outsides, we get 3 times the square root. Add those together, we have 6 times the square root. And multiply the last 3 times 3, and that's 9. Okay, this looks pretty messy. It kind of looks worse than it did to start with, but that's temporary. Let's clean it up by keeping the radical on one side and getting everything else to the other side. So I'm going to keep the 6 square root x plus 7, but I'm going to subtract x from both sides, subtract 7 from both sides, and subtract 9 from both sides. And after doing that, well, let me go back and fix my mistake from earlier. That should be minus there and there. Okay, after doing that, we have negative 20. Now, because we still have a square root in the equation, we're going to want to square both sides again. But would it be best, before we do that, to divide both sides by 6? I don't think so, because if we divide both sides by 6, we have a fraction over here, and then we're squaring the fraction, and then we're doing a bunch of other steps with the fraction, and that's not ideal. But I would divide both sides by 2. Makes the number smaller without introducing fractions. So once we've done that, we're ready to square both sides again. So we're squaring the left, squaring the right. This here is not a situation involving foiling because this is not 3 plus something or 3 minus something. It's just 3 times something. You can still write it out if you would like. Over here, when we square negative 10, we're going to get 100. So we have 3 times 3, 9, and then the square root times itself gives us x plus 7. Distribute the 9. 9x plus 63 equals 100. Subtract 63 from both sides. 9x equals 37. And divide by 9. 37 ninths appears to be the answer. But after all that work, it would be pretty wise to go ahead and check that answer. And there's another reason to check answers for this kind of problem. That is because when you square both sides of an equation, you might be introducing extraneous solutions, which are not solutions to the original equation. They were just solutions to the squared equation. So what we need to do is to take our solution, our answer, plug it into the original equation and see if it works. So we have the square root of 37/9 plus 7 plus 3 equals the square root of 37/9 minus 4. You can use your calculator. You're going to find that on the left you get 19/3 and on the right you get 1/3. So clearly that does not check. So our answer is actually not an answer to the original equation. It was just an answer to some equation we made along the way. We have no answer left, so there's no solution. If you were to look this up in the back of the book to check your answer, you would not see the words no solution. What our book likes to do is put this symbol, and that symbol is not the number 0. That symbol is empty set or null set, which means the same thing as no solution.